guys, so the warm-up was posted in Schoology. It's a Google form. Should take you about 10 minutes. You should have a conversation level 0. If you have any questions, raise your hand. You're working on the warm-up. Stay in your seat. Work on warm-up. Ask questions as needed. And you need your Chromebook, calculator, journal, all those things. All right, because we're going to get started right into work. We're getting right into work. So if you guys look, we have a very jam-packed calendar. We're doing scatter plots today, Wednesday. Thursday, we're going to start on trend lines, and then we have map testing. So your map testing Friday, Tuesday, Wednesday, and then we'll do a scatter plot gallery walk, and then we're going to be doing trend line, write and talk, and then we are reviewing Unit 6. I know, it's that fast. So that's how we're getting started super fast. All right, so if you guys get out your table of contents, we have page 22, 11, 9, 11, 10 scatter plots. That's what we're going to be working on. We're not going to do this because it only works when I'm there, and I really do like this activity, so we're just going to probably save it for when I get back. All right, so I'm going to skip all that, and then we're going to get started right with the notes. All right, so scatter plot. A scatter plot, a graph plotted points that shows relationship between two sets of data. So you have your x-axis, which is your fat axis. It goes from your left to right. And you have your skinny axis, which is your y-axis that goes up and down. So those are the two things. So it's on a thing. So this is going to be a positive correlation. You know it's positive because it goes in the direction of a positive slope. And it's strong because the data is close together. This is a weak negative because the data is a little bit spaced out, but still going through a trend. This last one has no association. And this one does have an association. It's just not linear. Okay? And that's all you need to know. All right. So now this goes back to the other thing that we were supposed to do, and we didn't do it. So I'm not worried about that. You're going to skip to this part. Scatter plot vocabulary. So we have miles per gallon, which is your variable. And then you have this, which is, these are your y variables. That would make more sense if I told you that. Your y variables or your dependent variables. And these are your x variables or your independent variables here. Okay? Then we have our outlier. This is just the data that just doesn't go along with the trend. We have a line of best fit or a trend line. It just takes the average of all your data. We have data points, which is just the data we collected. We have a negative correlation, so we know that it's negative. So the more miles per gallon you use, the price of the car decreases in thousands. So the more miles, the price decreases. All right. So here, baseball team shoe size. We do know it's a trend. It looks like it's going in a positive direction. So this is going to, actually it's a cluster. So this is debatable, but this is going to be a cluster because it's all bundled together. Okay, it can also be a positive linear relationship. Just depends on who you're asking. But for this vocabulary lesson, we're going to call it a cluster. This is a scatter plot or no correlation. That means like the data is scattered, it's everywhere. This is a positive linear correlation. It's linear because it's going in a straight line. And if I'm going too fast, you can pause the video and you can rewatch it as many times as you like. All right, key points. A scatter plot is a set of points plotted on a coordinate plane that shows relationship between two sets of data. The relationship can be positive or negative, or have a relationship or have no relationship at all. It can also be linear and nonlinear. So this is going to be a weak, positive, linear relationship. I don't think you need to know if it's weak or strong yet, but I think it's really important, so I'm going to say that. All right, so no, it's positive, it's linear. This is nonlinear, it's no correlation, no association, nonlinear. This is linear, it's negative, and it's a stronger correlation than the other one. Okay. Now, Kimberly and Brad are having a debate on the graph. Below represents the linear relationship between Kimberly believes graph A and represents the relationship, but Kimberly believes graph A represents a linear relationship, but Brad thinks that graph B represents a linear relationship. Who is correct? Now, if I look at this is a positive, strong relationship, but if I connect all the dots, it's creating a curve. Therefore, this is non-linear. And this one is basically making a straight line. So therefore, this one is going to be linear. So Brad is correct. Graph B is linear because it's making a straight line. Okay? Brad is correct because graph B approximates a line while graph A makes a curve. Or you can say what I said. Graph B is linear because it makes a straight line, which is more straightforward to me, but write what you like. All right. The table below describes the relationship between the number of cookies left in Mrs. Stevens' cookie jar and the number of days after they were baked. Okay, so this we know is going to be a strong negative correlation. So we know it's negative, it's linear. As time increases, the number of cookies decreases. Right? Which makes sense. The more you leave cookies out, the more likely they're going to be eaten. All right. Now what you guys are going to do is you're going to be doing Desmos. So you're going to make scatter plot on Desmos. In the upper left corner, you're going to click on the plus sign and choose a table. Enter all the values into the table. Zoom out if needed to see your plot. So you can play with Desmos and you can do this one on Desmos. Okay, so what would it look like? Okay, so we're going to go these directions and I'm going to pull up Desmos and I'm going to follow them with you so you understand what I'm talking about. So I got Desmos. I'm going to my graphing calculator and I'm going to click on the plus sign and I'm going to click on table. And that's going to give me a table. Okay, so if you guys, I'll backtrack or you can just rewind. That'll be better. All right. So now that I have Desmos, I'm like, oh no, go back. Okay, now that I have Desmos open, I'm going to make this a little bit bigger so I can see it. And I'm going to enter in all this data. 6, 8, 10, oh, look at that. 12, 14. This is going to be 8 again. 10, 12, 6, 7, and 9. I'm going to go back all the way to the top. And this is going to be 45, 50, 55, 59, 63, 48, 57, 62, 50, 45, 50. And yes, you can use this in the STAR test. So make sure you're utilizing what I'm saying. Then I'm going to zoom out so I can see the dots. And if you look here, zoom out, you can zoom back in. You can see their nice area. And you can pick up a relationship with this one. And what I see with this table of dots is this is a positive, strong, linear correlation. Okay, the dots are pretty much in a pattern. You know, you can get an average. You can put a line of best fit through them. And they're all going in a positive direction. So now that I've done that, I can go and answer these questions. So we know it's positive, we know it's linear, and we know as the age and years increases, the height also increases as well. So as you get older, you get taller, Depending on if you're a girl or boy, girls stop growing around 14 and boys keep growing until they're 22. I know it's unfair, but that's just what it is. All right, we're going to do this again. And hopefully you can do some Desmos on your own. I would encourage you guys to practice on your own. I'm going to do it again. So I'm on my Desmos calculator. I click my plus sign. Oh my God, if I can keep up with my screen, it keeps disappearing on me. All right. I'm going to leave it here for now, and then I'm probably going to do this off camera. So if you're confused with how these work, just know that this is going to be your X. If I have a pen. And this is going to be your Y. And you're going to need to line them up as so. So these numbers are going to be on the left side of your table, and these numbers are going to be on the right. Okay? And if you're confused, I would write it down first before you type it in. All right, so we're going to do 72, 68, 65, 73, 67, 78. Leave it down here. 71, 72, 75, 77, 77, 78. I'm going to scroll back at the top. And now this is going to be on my right side. So I'm going to do 85, 87, 62, 78, 78. 58, 24, 45, 52, 87, 79, 90. Let me trash this. And now that we have this done, we can kind of zoom out and we can look at it. Now, believe it or not, this is linear. But I would think that the association is undefined because it's just going straight up and down. It's not going in a positive direction. It's not going in a negative direction. It's just going straight up and down. So I would say that this data is more of a cluster or undefined. It is linear. But they said it's no relationship. So no relationship. They called it nonlinear. So I guess it just depends on who you ask. I guess because it's undefined, they would say it's no relationship because it's technically not a function and it's no association. Okay? So there's no relationship between the height and number of points that you get. It's just kind of all random. And when it's up and down like that, you're going to treat it like a scatter plot. All right. Now, once you've done the notes, you're going to make sure you get these two IXL codes until you get 100. I will be checking, so make sure you get them done. And I will see you guys when I get back. Have a great day. Bye.